Welcome to the Explainer. Today, we're diving into something pretty wild, a new patent that's all about an AI team that actually manages itself. Yeah, you heard that right, a team with no boss. So let's get into it, because this could totally flip the script on how we build massive AI systems. Okay, so let's just start with this huge question that's bugging pretty much every AI developer out there. How in the world do you manage a million AI agents all at once? I mean, seriously, how do you get them all to work together without the whole system just, collapsing into a complete mess? Well, for the longest time, the go-to answer has always been centralized control. You have one big master system, one central brain, telling all the little worker agents what to do. But that old way, it's really starting to show its cracks. It's breaking down. So today, we're going to look at the new way, a pretty radical idea where at the team, well, it manages itself. All right, so to really get why this old model is failing, we need to talk about what I like to call the AI traffic jam. This is the core problem, the big bottleneck that this whole new patent is built to completely demolish. And look, don't just take my word for it. This isn't just me making up a catchy name. The patent itself says that these central orchestrators, basically the single bosses, they create massive scalability and reliability issues. So this isn't some minor headache, it's a fundamental flaw in the design. To really wrap your head around this, just try to picture one single air traffic controller. But they're not just at one airport. They're trying to manage every single takeoff, every single landing, for every plane at every airport on the entire planet, all at the same time. It's not just hard, it's completely impossible, right? Well, that's pretty much what's happening inside these old school AI systems. And this creates a whole cascade of problems. I mean, it's a full-blown crisis for these systems. For one, you've got a single point of failure. If that one central controller goes down, boom, the entire system's dead in the water. It's also a massive performance bottleneck, slowing everything to a crawl. It hogs a ton of memory just trying to keep track of everything. And get this, if you want to update anything, you have to take the whole system offline. Oh, and the worst part? It's a total black box. It's incredibly hard to see what's actually happening inside. Okay, so if the single traffic controller is the problem, what's the solution? Well, the answer is to get rid of the controller altogether. The solution is a decentralized system they're calling the multi-agent network, or MAN for short. So what is MAN? Put simply, it's a system where the AI agents themselves can figure things out on their own. They talk to each other, they delegate tasks, they make decisions as a group, all without ever needing to phone home to some central boss for permission. They're autonomous. And you've got to understand, this is way more than just a clever bit of engineering. It's a whole new philosophy. We're talking about a shift from that rigid top-down command structure to a flexible, collaborative network. Instead of a boss and workers, you just have a team. Okay, so that all sounds amazing, right? But how does it actually work? I mean, how do you stop a million agents from just descending into chaos? Well, it all starts with a really clever blueprint, a structure built on three distinct layers. Think of it like a perfect division of labor. First up, you've got the decision layer. These are the thinkers. Their job is to take a big, messy goal and break it down into small, bite-sized tasks. Then you have the execution layer. These are your doers. They're the specialists that just grab one of those small tasks and get it done. And finally, there's the interface layer. These are the diplomats. They handle all the talking to the outside world, grabbing data from a database or calling an API. All right, but in a system with no boss, how do you keep track of anything? How do you know who's doing what? The secret sauce here is something called a flow ID. It's basically a unique digital tag that gets slapped onto a task the moment it's created. Seriously, just think of it like the ultimate unlosable tracking number. This little ID sticks with that task no matter what. As it gets broken down, passed from a thinker to a doer, the ID goes with it. This creates a perfect unbroken chain, an audit trail for every single thing that happens. And just like that, the whole black box problem, it's solved. Okay, so we have the team structure and we know how they track their work, but two big questions remain. How does one agent find the right teammate for a specific job? And how do they all agree on what to do without a boss to make the final call? And the way they solve this is just brilliant. Instead of some clunky central phone book of all the agents, they use what's called a gossip protocol. It works just like it sounds. A new agent joins the network and it just tells a few of its neighbors, Hey, I'm new here, and I'm really good at, say, image analysis. Then those neighbors tell their neighbors, and so on. The information just spreads organically like a social network for AIs. And what about making decisions? Again, no waiting for a manager's approval. They use this super fast, lightweight consensus system. It's basically a vote. One agent says, hey, I think we should do this. It sends that proposal to a few of its peers. They quickly vote yes or no. If it gets enough yes votes to reach a quorum, then boom, the decision is made and locked in. It's fast, it's democratic, and it keeps things moving. But how does it pick not just any teammate, but the best one for the job? Well, it uses a really smart adaptive routing system. It's basically a little scorecard. For any potential teammate, it asks three simple questions. 1, do you have the right skills for the specific task? 2, what's your performance history been like? Are you reliable? And 3, what's your current workload? Are you too busy right now? By weighing those factors, it can intelligently route every task to the absolute best agent for the job, every single time. So we've gone through all the theory, which is really cool, but does it actually work in practice? What are the results? Well, this is where it gets really impressive. Let's look at the actual payoff, the hard numbers. Check this out. Just look at memory usage. For a tiny network of only 10 agents, the old centralized way eats up 60 megabytes of memory. The man system, only 15. That is a 75% reduction. Now, just try to imagine what that kind of saving looks like when you scale it up to thousands or millions of agents. It's staggering. And it's not just memory. Look at this, the time it takes to update an agent. In the old system, you have to do a full restart. We're talking 30 seconds or more of downtime. That's an eternity in the digital world. With Man, you can do what's called a hot swap. You pull an agent out and put a new one in less than 100 milliseconds. That means zero downtime. The system literally never has to stop. And this isn't just about cool tech specs. This has huge real-world impact. Think about it. A bank could run thousands of incredibly complex risk simulations all at the same time and have a perfect, bulletproof audit trail for every single one. Or imagine a hospital using this to optimize schedules for doctors, nurses, and patients in real time, making everything more efficient while keeping all that sensitive patient data secure. The possibilities here are just enormous. So let's just end on this thought. What we're looking at here isn't just a patent for a more efficient piece of software. It's a blueprint for a whole new kind of intelligence, one that's autonomous, collaborative, and self-organizing. And it kind of leaves you with a big question, right? If AI can get this good at organizing itself to solve the problems we give it, what happens when it starts deciding which problems to solve next?